Yeah. How's everybody doing today?
Yeah.
Yes.
You have plenty awake after lunch? Yeah? Yeah? Come on.
Me too.
All right.
Do we have to do something to make the
Is that 2?
the main?
No, 5? Do I need a
5. Yeah, that's right.
Haha, okay.
Perfect.
Welcome to deploying containerized and serverless apps using Terraform with Kubernetes, AKS, and Azure Functions. I'm Christy Kaler. I'm a developer advocate at HashiCorp, which is the maker of Terraform and some other tools that I'll mention as well. Our developer advocacy team is 3 people strong, and we focus on working with open source practitioners to learn how to use our tools. And my background is a mix of ops and web application development, and I come from sort of Unix open or Linux open source land. So it's really cool to be here and to sort of be learning about all the really cool stuff that Microsoft is doing in this space. And someone who knows a lot about that is my co-presenter, Zach.
Yes. So my name is Zachary Deptawa. I'm a cloud developer advocate for Microsoft. You can find me on Twitter at @zdeptawa there. Also, if you feel like tweeting, you don't have to, but if you do, if you want to use the hashtags MSIgnite and BRK3194, we'll be able to check that later and see how everybody felt about that. A little bit about my background. I come from the old days of dedicated hosting, and I've been all over the industry, mostly the hosting industry, and touched a lot of different areas throughout that time. So let's get started with the spoilers, AKA the agenda. What we're going to cover today is we'll go over HashiCorp and Microsoft Azure and a little bit about the partnership between the two. We'll go into an introduction to containers, orchestrators, and serverless functions. And the reason we're going to cover an introduction is just so everyone's on a similar page, just in case there's anybody who's not familiar with these things. Actually, who here has never used Terraform? Right on. OK, cool. So I think we've got the right level. We'll go into an introduction to HashiCorp Terraform, some of the basics about Terraform. We will do a demo with those basics just to show how it all looks when you use it. And then we'll go into an introduction into the Azure Kubernetes Service, some background there as well. Do a demo deploying containerized apps on top of AKS with Terraform. And then we will do an introduction to Azure Functions. We'll do another demo that shows deploying Azure Functions using Terraform. And after that, we'll close with some next steps and some getting started. This is a really, really long session today, so we've got a lot of stuff that we're going to cover, and we'll do some Q&A at the end.
So HashiCorp, I want to give a little overview because we're kind of a little tiny company, and sometimes we're better known for our tools than we are, as HashiCorp. How many of you have heard of HashiCorp and know that we make Terraform? Okay, pretty good. So we were founded in 2012 by Mitchell Hashimoto, hence the name, and Armand Dadgar. And the two of them met as students at University of Washington. And there they worked on research together in distributed systems and also what we would now consider cloud infrastructure deployment. After graduation, they were working for a bit, and Mitchell was working in an agency and developed an open source project called Vagrant to make setting up development environments easier. And how many of you have used Vagrant? Pretty good, yeah. Vagrant really took off. And so in 2012, Armand and Mitchell said, also noticing that as this cloud infrastructure stuff was evolving, that there was kind of a gap in the tooling around it. They said, OK, let's build on what we've learned in school and making Vagrant and form a company and work on this stuff together. So HashiCorp's mission is to allow organizations to provision, secure, connect, and run any infrastructure for any application. Right now we have 6 products. I'll talk about them a little bit more in just a moment. I wanted to mention the DAO of HashiCorp, and one of the reasons I really like to mention this in talks is because it's something that I'm really proud of. It's sort of our principles for how we design our products. And I'm not going to go through the whole thing, just the 2 first things. One of them is workflows, not technologies. So we recognize that Technologies change over time, and one of the biggest goals with our products is to provide consistent workflows and to have that be the focus of our products. And we also try to design products that are simple, modular, and composable. This sort of comes from the Unix philosophy. So we focus on making products that do things in a particular scope really well and that can be combined with other tools kind of together. So that means that all of our products work together, and they're also designed to work with other products you're already using in your infrastructure. Here's a quick overview of our product suite. We take those 6 products and we kind of divide them into 4 layers. So we have the provision layer, which includes Terraform, which allows you to plan and create infrastructure. Packer, which is automated machine images. Vagrant, I already mentioned. Then we have that secure layer with Vault, which is our secrets management. We have a run layer with Nomad, which is our container manager and scheduler. And then Connect with Console, which is our service mesh discovery thing. All of our tools have an open source version, which is free to download. And then we have enterprise offerings. Another thing that I really appreciate about HashiCorp is how we approach the sort of open source and enterprise. So we approach it with the open source tooling addresses the technical complexity. And so our open source offering is very fully featured. And then at the enterprise level, we try to solve problems around organizational complexity. So things like governance and the sorts of issues that come up when you're collaborating with a lot of different people. I'm going to hand it off to Zach to talk about some Microsoft stuff.
All right. So I am not in sales, so I'll be really short here and be really quick through this. So Microsoft Azure, these are really the 4 pillars that I think about when I think about Microsoft Azure. We care about productivity. We want people to be able to get their work done as easily as possible and as smoothly as possible. We care about true hybrid interaction. We care about intelligent clouds. AI, cognitive services. If you haven't checked out our machine learning and cognitive services, I implore you to do so. And trust. We are a highly trusted cloud. We are used by companies and large corporations that require really, really stringent security requirements. And that's something that we, one of our 4 pillars that we really care about there. So simply put, Microsoft Azure is a productive, hybrid, intelligent, and highly trusted cloud. And so I also, being a Linux engineer, my whole background is Linux, which is kind of crazy that I'm standing up here at a Microsoft conference giving a talk. But when I moved over, I had a lot of people that said, what are you doing? You went to Microsoft. You're a Linux guy. Microsoft doesn't like open source. They don't like Linux. You know, what's going on with that? And so I just asked them this one question. You Azure about that? That's right. Because, and honestly, I've been here a little over a year, and I felt the same way as a lot of my friends and colleagues who thought the same thing. And being here, being inside and seeing how this works, we care mostly about open source at this point. It's kind of amazing. It's one of the coolest things about my job right now is I get to work on open source and give talks like this, and not even mention really Windows except right there where I mentioned it. And that's the last bad joke that I'll put in this slide. So, but I answer them with this too. You've got to be kidding me. Okay, this is the last joke. That's one of my goats, Nacho, though. But yeah, Microsoft loves Linux, and it's true. There are so many Linux engineers. I feel like I know more Linux engineers internally at Microsoft than I do anything else, which is pretty cool. Okay. And then here, obligatory, Microsoft loves open source slide as well. So Microsoft Azure and HashiCorp Terraform. Because we care so much about open source, really cool tools like Terraform that are open source, we partner as much as we can with those companies, those tools, to make sure that they work really well on Azure. And Microsoft and HashiCorp have, I think it's a several-year relationship that we've been partnering. We have engineering resources that we spend, time that we spend building things and building providers and submitting code for Terraform. And on the same token, HashiCorp spends a lot of time developing for Azure-related providers and resources. And we will actually give access to HashiCorp to see new releases that are coming out. So hopefully when that release launches, we have a resource in place inside of Terraform. It won't be something that's delayed. But we have an entire team, really, that partners with Terraform. And just to give you an idea, I'm a cloud developer advocate for Microsoft. My primary focus is not infrastructure as code, but I'm one of the people that also partners with Terraform very heavily. So we're very invested in that. So now let's go into Microsoft Azure on containers, kind of how Microsoft feels about containers. So the Microsoft Azure container strategy, we think containers are everywhere, and we use them across our entire portfolio. And what we really care about, what we want to do is we want to democratize container technology. We want to make it super easy to use, and we want to make it very easy to use on Azure. And what we hear from developers in terms of container technology and this kind of subject is that they want to be able to create applications really quickly, and they don't want to be hindered by things like waiting for IT, waiting for gear to be spun up. And they don't want to be blocked at all. They just want that quick closed loop as they're developing and as they're testing. And they want to know when they push that out, it's going to be the same as how they were testing. They don't want any funny business, worked in dev kind of thing. And what we hear from IT on the opposite side is they want to minimize risk. That's their primary focus. They want the infrastructure solid, they want it secure, they want it stable, and they don't want no funny business. They also, and I come from this background as well, so a lot of times infrastructure folks don't have the bandwidth to fully understand the application on a very, very deep level. So they care about building the infrastructure, and then they want the dev part to just work on top of their infrastructure. And sometimes there is a discrepancy there, and that's why containers are super cool. The developers get that fast iteration, they get agile delivery, they get immutability, and IT also gets cost savings, the ability to have things deployed more densely, elastic bursting, and everything works like magic as things do. And industry analysts agree, it's not just us that's hearing this. By 2020, more than 50% of enterprises will run mission-critical containerized cloud-native applications in production, up from less than 5% today. That's a pretty staggering number in terms of the difference there. We're not too far from 2020. How crazy is that? And this is just another marketing-like slide. Containers are gaining momentum. The really cool thing here is nearly 60% of organizations running 500 or more hosts are classified as container dabblers or adopters. And that's not small companies. That's large companies that are running more than 500 hosts. That's a pretty big number. Now we'll jump into some container 101 real quick, just give some background on containers. So what is a container? So containers, they're often referred to as operating system level virtualization. Back in the day or even today, back in yesterday, virtual machines are logically isolated pieces of a hypervisor that have their own overhead. They have their operating system, their drivers, a lot more overhead than a container that's sharing those heavy pieces with the operating system that's underlying. And so I probably didn't answer that well. A container is basically a logically isolated piece of the operating system, everything that you need for a process or an application inside a small container. And what else is a container? It is not a real thing. It is an application delivery mechanism that can see basically process isolation based on Linux kernel features. It can see namespaces, things like the PID or the process ID, the mount, the network, and C groups, things that it can use like memory, I/O, CPU. And what is Docker? Who here has heard of Docker? Right on, okay. So yeah, Docker is an open source container runtime, runs on Mac, Windows, and Linux, and it is a command line tool. It's pretty easy to use. Docker file format is what it uses for building its container images, and the Docker image format uses a layered file system, and I'll touch on that in just a second because I think it's pretty sweet. But yeah, more on that in a second. This is just a sample Docker file. That all it's doing is it's building an image from scratch, which is, just consider that an empty image, a completely empty image. And it's copying this hello over to root. It's going to run that command. That's all this image is doing. And so to build that, docker build-t hello world, and that will actually tag it as hello world, and you can run it with docker run hello world. So super straightforward. And that does say the world's simplest Docker file. I don't know if that's true or not, but it says it in the comments, so it must be. This is the Docker layered file system. There's more information about this, but what I really want to convey is when you build an image, say you build an image using Docker, if you change something about that image and you go to rebuild it, the way the Docker layered file system works, think of it as a GitHub repository with hashes. You know, as you're committing, you've got these hashes, and you can actually see them there for this layered file system. If you make a change to an image and you rebuild it, it's only going to rebuild from that point forward, so it doesn't have to do the entire rebuild process. And that's one of the coolest parts of the Docker layered file system. That's all I wanted to mention. So the container advantage, traditional virtualized environment. I'll go back a little bit and maybe show my age here. But back in the days of dedicated hosting, when you had to possibly request an entire cabinet and then request servers to be built, and it took weeks and sometimes over a month, depending on how complex the configuration was, and you had to get things cabled, NetSec, and DC ops, and all of these things. We realized that we had all this server capacity that was slow to build, and it took a long time to get things up and running in QC, and you had to install things afterward. It just was very clunky. And then we realized we had all this overhead on this gear that we had built to meet this peak that happens one time a year. And so we looked at virtualization. We could fill that overhead with VMs if we wanted to. And so that's where VMs came into play. And now we have all these VMs that have all this underutilized space on top of them. And that's where you can have higher density with containers. And this graphic here is just showing 2 VMs that have some containers on there. And so you can easily migrate those containers much easier than, say, migrating VMs in a traditional sense. You don't have to worry about all that overhead. They spin up much quicker because they're sharing the overhead. And you can see here you can decommission that old resource as well. Or say there's a failure, that migration could happen automatically if you're using an orchestrator. Speaking of orchestrators, let's talk about those. So what are some of the elements of a orchestrator? Scheduling, affinity, anti-affinity, which means placing resources closely together for performance reasons or placing them far apart for reasons like DR or some other reason where they need to be far apart. Health monitoring of your resources, automatic failover, automatic scaling, networking, service discovery, so one container can find another container within the environment, and coordinated app upgrades. And that's where Kubernetes comes in. Who here has heard of Kubernetes besides the name of this? Oh, right on, okay. Who here uses Kubernetes today? Awesome, okay. So Kubernetes, just really quickly for anyone who's not familiar, it's a portable orchestrator, and you can use it on public, private cloud. You can have it in a hybrid multi-cloud environment. It's extensible, very hookable, pluggable. And it has self-healing, the really cool stuff, like the auto-replacement, auto-restart, auto-replication, and auto-scaling. Really neat things. And Kubernetes does empower you to do more. You can deploy your apps quickly. You can deploy them reliably. It will scale your applications on the fly. And you can roll out new features seamlessly. And the really cool part, you're limiting the hardware usage to required resources only. Being it's an orchestrator, you tell it, here are your resources, here's what I need from you, you figure out how to deploy that stuff, I don't want to think about it. And that's what the orchestrator does. It manages and makes sure you have n number of that application or container running at any given time. Now we're going to go to a quick introduction for Terraform.
Yeah, so show of hands again, how many of you have used Terraform before? Okay, so this will be familiar to some of you. The purpose of this is basically to give you enough information so that when we do the demos, they'll make sense. So in designing Terraform, we have these use cases in mind. First, we want for you to be able to do infrastructure as code. So what we mean by this is that when you are defining your infrastructure in code, it means that the deployments are effective, reusable, and safe in automation, right? We also support, I mentioned this earlier, but hybrid or multi-cloud environments. So this maybe you're deploying to Azure and AWS, or maybe it's a mix of cloud and on-prem. And what's cool about this is that we enable a common workflow across these different infrastructure providers. And really, we want to provide self-service infrastructure. So we want the devs to be able to pick the best infrastructure workflow for their apps, and operators to be able to have reusable modules that developers can use, reusable modules that provide best practices for their infrastructure that developers can use, and have this all be self-service. And ideally, this allows you to write and collaborate on infrastructure in version control, plan, validate, see your changes before you actually execute them with this common workflow, make sure you're going to get the infrastructure that you want, and then, again, create that reproducible, automated infrastructure deployments safely. I've talked a lot about workflow here, so this is Terraform's workflow. And it's basically, it's the same, or it's similar from day one and then all the days after, but I kind of wanted to differentiate here. So if you're just starting with Terraform, or if you're just, not just starting, but if you're starting a new deploy, you have some configuration checked out already, or maybe you've written some. First, you do a Terraform init. And what this does is tells Terraform init, or initializes a state file. The state file is basically a catalog of all the infrastructure resources that Terraform is tracking. And it also downloads all the things that Terraform needs, any providers you've defined, provisioners, modules, things like that. You have your configuration, you run a Terraform plan. And what Terraform does is it takes all the configuration, looks at it, creates a dependency graph, looks at your state file, the existing state of your infrastructure. If you're just starting, there won't be anything in there, and spits out a plan and says, hey, this is what we're going to do. We're going to create these resources, destroy these. That all looks good. You run a Terraform apply. And then Terraform works with the providers, and the providers all make the API calls to make that infrastructure happen. Now, after day one, you continue iterating on your infrastructure, building it out, things like that. So you can do this manually, but also Terraform, before you run any commands, will do a refresh. And that's a refresh of the state file. So it goes out and it queries all the infrastructure to see what's running out there. Because how many of you have experienced where you have some kind of orchestration and configuration management, but you actually get drift because people change things in the portal? Right, okay. So this is part of managing drift with Terraform. There's actually a blog post up on HashiCorp blog about this that I wrote. You should check it out. So you run a refresh, then the state file is updated. Now when you run a plan, Terraform looks at your configuration, that ideal state that you want, looks at what's actually happening, tells you a plan, you apply. And I've put the destroy in here. Destroy is kind of a specialized apply. It's basically like, what do we need to undo all that infrastructure that we've created? So operational simplicity is another thing that HashiCorp really strives for. Terraform is a single binary download. We have pre-compiled binaries for Linux, Mac, Windows, and then you can build it for a number of platforms. The Terraform core is responsible for looking at all those configuration files, parsing them, building that dependency graph, and it's also responsible for managing that state. In conjunction with core, there's all the Terraform providers. And these are Go binaries that are written to specifically query the different infrastructure provider APIs. And they're the things that actually define the different resources, infrastructure resources that are available to you in your Terraform config. We have over 100 providers, a bunch of them for Azure, that provide thousands of different resources. And one of the things that's really cool, at least I think it's cool, is that we're not just talking about infrastructure of a service. You can, basically anything that has an API in a sense of lifecycle, you can have a Terraform provider for. So like if you want to manage your GitHub teams in Terraform, you can do that. A couple more things that are important. Provisioners are scripts that execute upon resource create or destroy, you specify which. And you can use this for configuration management, bootstrapping, cleaning up things before you destroy them. Maybe you want to do some, you want to migrate something before you destroy a resource. There's different kinds of provisioners, local exec, remote exec, chef, and you can write your own. I think I mentioned modules earlier, but that allows you to basically package up sets of Terraform configurations for reuse, versioning, allows you to black box or abstract deploy some infrastructure so people can just download a module and put in their variables and deploy. We also have public and Terraform Enterprise. You can do private registries. So if there's module reuse you just want to share within your organization, you can do that. There's a whole bunch of existing modules for Microsoft Azure. Lastly, backends. I mentioned state. Backends are the thing that determine how state is stored and to a certain extent how applies are executed. The default state is local. It's just a file on the local disk. But there are different backends you can choose, and many of them are stored remotely. So Azure Console, which is our product, S3, things like that. And that allows things like collaboration, and also, if your local machine, something happens to it, you don't have that state just locally. Here's a quick screenshot from Terraform Enterprise. Really cool looking UI. And this is what I was talking about that provides some additional features for that organizational complexity. So you can define workflows for automatic applies. So someone submits a plan to GitHub. Terraform Enterprise sees that, says, oh, OK, that person, their plans get automatically applied, and Terraform applies it. Oh, no, that person, they need some approval process. We have a governance policy framework language called Sentinel. Do that. Something to check out. OK, who's ready for a demo? I'm ready for a demo.
Yeah.
All right, we're going to do a quick Hello World demo, and then we have to do that first.
Yes.
Yes, it worked. OK, is that mostly visible? Should we try to make it bigger?
You can try, yeah.
Who can see? OK.
OK.
Oh, we need to make it bigger.
Is it, yeah?
You do it.
Yeah, let's
I can't
try
remember, is it? Keep
Is
going.
this better?
Tell us when. How many can see now? Oh, a little more.
A little more?
This will be fun. OK.
Cool.
OK, so how many of you used the Cloud Shell before?
Nice.
Awesome. Yeah, it's someone I've spent a lot of time helping open source projects like work on their new contributor workflow. I am so jazzed about Cloud Shell because of how quickly you can get going with something. So this is part of the Azure portal, and it's this prompty looking thing up here. And when you launch it, it opens a container, right?
Yeah, it's basically opening a container on the back end, and it's attaching some persistent storage to that environment, and it's delivering you this shell prompt here. So anything you do in there, if you drop a file, as long as you have that storage set up properly, and it will do this all for you, it will persist.
And one thing that's really cool is it has a lot of stuff pre-installed that you need. So Git's there, and Terraform is there. I promise we didn't install any of this. It came with it. One thing we did do is we checked out some demo code, which I think I need to go to. Yes.
Yeah.
So Terraform and Azure 01. No, demos?
Yeah.
Demos 01, rock on. OK. So if we look here, we've got our Terraform thing. We don't have anything else. Another cool thing is there's a version of VS Code in here. So if I go code at, ooh, that's not how you spell it. OK, so what we're going to do here is we're going to use the Azure-RM provider to create a resource group, and within that, or attached to that, a network with a couple of subnets. So here's our, oh, I forgot to mention the configuration language. So Terraform uses the HashiCorp configuration language, HCL. It looks like this. It is JSON compatible. So here we say the provider we want to use is AzureRM. I don't know how to scroll. Here we're creating a resource group. So we want to create and now remember how I said the providers expose those resources? That's an example here. Azure resource group. We want to call it Demo 01 resource group. Give this name, and this is what Terraform calls it. This is a name that will show up in the portal. This is our location. Doing good so far?
Yeah.
We're going to give it some tags. We're going to create a virtual network. Within Terraform, we call it this Demo 01. Same thing in the portal. It's got some addresses. Here's some variable interpretation, so you don't have to be hard coding everything. And we've got there's a new version of Terraform coming out soon that has a lot of really cool improvements to HCL, including awesome stuff with the variables and the interpolation. Here's our subnets. Okay. So now we got to do our init, Terraform init. Chicken, it's going to make sure we have some modules.
Yes.
And so now, did it do it right?
It did, yeah.
Okay.
Let me expand this real quick just so.
I'm going to do like 3 lines at a time, like old school.
There you go.
All right. So now if we look, we've got a Terraform directory in there. And now we do Terraform plan. And why do I, is it that, Zach? Is it 2 dashes or 1?
Oh, just 1. So this Terraform plan that she's running here, it's going to output the plan into this plan.out file, which is pretty cool. You don't have to do this, but what this does is it creates that plan file. You can share that plan file with, across your organization or send it to someone who can make the decision on whether or not you should be doing that kind of thing. And it's not human readable. You'd have to use Terraform show and then the plan file name to see it, but it's pretty powerful.
And if you don't output to a file, when you go to do an apply, if you don't specify anything, Terraform will replan. So the other reason to do the output to a plan is that then you can run that specific plan, and you know that that's what you're running. So we get a bunch of output here. Go to the top. It says, OK, refreshing state. We're going to create, and here's the things we're going to create. Here's different values. Now you see it differentiates between the things we've set and the things that are going to be computed. Now we go Terraform, apply. Do I just say?
Mm-hmm.
Thank you. Plan.out.
Cool. Yeah, and if you look here in the, yeah.
Go to the portal now. See? Is it totally done? It's totally done. So if we go here, I got to make this smaller. Wait, can I just close this?
Yeah, you can just close it out. There you go.
So there's our resource group and our network. There we go. Where's the subnets?
Yep.
All right.
Awesome.
Zach?
Yeah, and so to show real quick too, if you wanted to say add to, say you wanted to add a subnet here, you could, and let me just open this back up, see if I can do this quickly, just to show the difference in state here. I'm going to go back to this directory real quick, and let me open up code. And this is really cool. If you haven't played with VS Code in the Cloud Shell, it's built right in. I didn't have to install this. Okay, so say we wanted to, what do we want to do? We want to add another subnet. Let's do that. Let's just call it private subnet 2. Give it a .3 here. Save this. And now if I do a Terraform plan, and I'm not giving it an out file here, it should run. And you can see here it has 1 to change. So there are certain things that you can change in your Terraform code where it would require rebuilding that resource. But because I'm only adding a subnet to a network, it only needs to change that network by adding that subnet. In Azure, it wouldn't need to rebuild the entire network. So yeah.
Cool.
Cool.
And then back to you for
this one. I think. Yes. Okay, cool. So let's talk a little bit about the Azure Kubernetes Service, or AKS. We use a lot of acronyms, and I try to make sure that I mention what they are first. But if you hear me say AKS, I'm just referring to the Azure Kubernetes Service. So the Azure Kubernetes Service is basically managed container runtime experience using Kubernetes. It's managed Kubernetes on top of Azure. You can focus on your containers and not on the infrastructure, and that's super powerful. You can handle patching and upgrading. Who here loves doing patching and upgrading? No, me neither. So you don't have to worry about that with the Azure Kubernetes Service because we manage all that for you. And you can scale and run your applications with confidence. You can do all this through the portal. You can do it through the command line tool, the AZ CLI tool, or you can also do this with Terraform, which we'll show you today. And this is another slide that really says the same thing. But the most important part here is all the heavy lifting is done by us. You only focus on your code. You don't have to worry about all this infrastructure business. We can focus on that for you. So getting started with the Azure Kubernetes Service, just in general, is really easy. If you wanted to use the CLI tool, you can see that here. AKS create will create that cluster for you. AKS install CLI. If you don't already have kubectl, which is a tool for managing Kubernetes, if you don't already have that installed, AKS install CLI will install that for you. And AKS get credentials, if you can feed it the resource group and the cluster name, it will grab all the information to authenticate to that cluster, and it will set it as your context. So these 3 commands, after you're done running those, you can do kubectl get nodes or get services, and it's going to be connecting to your cluster as the context. And here's a few more commands. AKS list will list the clusters that you have. AKS upgrade, you can actually specify the Kubernetes version that you need, and it will upgrade to that version. And you can see at the top here, the Kubernetes release was 1.7.7 on this particular image. It's upgraded to 1.8.1, and you can see that change there when you do get nodes. And AKS scale seems like a super simple command, and it's simple to run. This is to scale that 3 node to a 10 node. And it is very simple to run, but what it's doing on the back end is very powerful. It's actually taking those nodes and making them, it will do upgrades where it will make things unschedulable. It will not basically break things when you make changes, when you upgrade the environment. A scale like this is simply going to scale those nodes out, but when you do updates and when you do these changes, Kubernetes, the managed Kubernetes service that we have, will do them in a way that's non-breaking. And that's important. You don't want things to just be replaced as they are. The other cool thing is Terraform, because it is abstracting our API. Anything that you do with our API is going to happen the same way through Terraform that it does with the with the Azure API. And that's just because Terraform is actually communicating with our API. It's just doing it in a more easy to read fashion. And a lot of our customers will deploy using the CLI tool because it's pretty straightforward, or deploy using an infrastructure as code tool like Terraform. But you can do that in the portal. Hopefully that's not too small to see there, but under containers you can see the Kubernetes service. There's also a link to a quick start tutorial there in the portal. Okay, now we'll do another demo about deploying an AKS cluster. Let's switch this back over. Are we back? Okay. Let's take a look at where I am. Okay, so I've got, let me make sure I'm in the right place here. I've got this code, and I'll run through it really quickly. You can see this is my directory. I'm using VS Code here. This is a free editor that it's very extensible. There's lots of extensions that are made for it. You can see its syntax highlighting for Terraform. I'm using the Terraform extension in VS Code. It also does IntelliSense, which is really cool. But I've got a main.tf file. And I'll step back really quickly. All the TF files in this directory are going to be looked at by Terraform. And Terraform is going to figure out what needs to be run and how it needs to be run. So if you have a lot of resources that you're building and you're doing the attribute interpolation that Christy mentioned, it's going to understand that a resource group has to be built before I can reference it. And so it's going to do things that it can do in parallel, just so things can get done quickly. But things that it can't do, it builds a dependency graph, and it does them in the order that it needs to do, which is super powerful.
Real quick, can folks read the text okay?
Oh, yeah, you want me to zoom this?
Who can read this?
Okay.
Okay.
Perfect, thank you. So you don't have to split these out into separate files like I have here. You can see in my directory, I have a main.tf. I have a output.tf file. I've got a variables file. This variables file, we can start there. Actually, it shows these variables that I'm setting that I can use in my Terraform code. Client ID and client secret, I'm simply initializing. I'm setting those in environment variables. So they're left blank, but I want to initialize them here. I'm setting an environment tag, which is just a tag that's set inside of Azure, so I can easily find this later. I'm going to set a build tag as well for this demo. The agent count is going to be the number of nodes that I'm deploying inside of the AKS cluster. I'm going to set my public key here. And DNS prefix, this is going to be the prefix for hitting that cluster. Cluster name I'm just naming here. Resource group I'm naming here. I'm going to put this in East US. And this variable here at the bottom is about the functions. This is going to be a demo later, but this is basically a URL inside of my Git repository to this zip file that contains my function information. So if we take a look at the main.tf file, I'm setting the provider. The provider is AzureRM here. And I'm also going to set the backend to local. So as Christy mentioned earlier, you can use different backends in Terraform. You could also use the AzureRM backend here, and that would actually store your state inside of a storage container on Azure. And that's really powerful because if you have a Terraform state, I'm actually going to track it locally here for this demo. But say I made some changes, and someone else went to make changes to the same environment. If I didn't push that state file up, and if they didn't consume that state file, they might not be in the same state. We would have drift because my state file is local. If you're using a remote state, everyone can use that same state for the same project. But for this purposes of this, I'm going to use the local backend. This k8s.tf is building my Kubernetes cluster. I'm also building the resource group here. You can see I'm using the variable to do that for the name and location. I'm setting my tags, as I mentioned there in the variables. I'm going to create the Kubernetes cluster using this resource inside of my AzureRM provider. And I'm setting the name using a variable, but I'm interpolating the location and the resource group. I could use the variables there, but using the interpolation makes sure that whatever is computed for that resource is what actually gets pulled. I'm setting my DNS prefix here. I'm going to set my username, my SSH key information, and I'm also setting the information about the nodes here. I'm using the standard DS2 v2 VM size. OS type is Linux. The agent count is set here. And I'm using a service principal to actually launch this Kubernetes cluster. And service principal is basically credentials that you create inside of Azure that allows something to run on behalf. It's more secure of a manner than if I was going to say, here are my main keys, use these to go do something. I built this service principal instead. And I'm also tagging this as well here. And I'm going to deploy a pod on top of it. So the pod, right here, I'm actually changing my provider. So Azure is a big hosting company, right, or a big company that has hosting. But this provider is for Kubernetes. So that means that I can deploy to any Kubernetes cluster anywhere as long as I can access the host and as long as I have the credentials using this provider in Terraform. So just to show a little bit of I guess, differentiation, anything that has that API in the sense of life cycle, you can have a provider for in Terraform. You can use the username and password, but instead I'm using client cert, client key, client CA cert here, and I'm interpolating this as well from what's being generated. I'm going to name it Ignite Nginx pod in the metadata. And I'm going to use Nginx 179 and just name it example. And I'm also going to put a service. So I'm deploying an Nginx pod, and I'm also deploying a service that I can connect to as well to that pod. So I'm using port 80 type load balancer so I can get an IP address to hit that. And I'm also interpolating here. I'm basically pulling from the metadata name that I've set here to link this service to that pod. And there's also some function code here that we'll go over later. But let's take a look at what this looks like on the command line if I can find where I'm going. Sorry about all this. All right. So this should be the right directory for me. I'm going to do a Terraform. Well, actually, first, let me go over something really quickly here. You can see this sample env var.sh file. This is a very basic, basically an sh file that I'm exporting my credentials for. So Terraform can consume environment variables. And you can see at the bottom, tf-var would actually be seen as a variable inside of Terraform. So I'm going to basically export this so I don't have to put these credentials anywhere in any files. It's going to pull it from my environment variables local. The last thing you want to do is push your credential information up into some repository somewhere. So if I want, I can show you how I source that. So now I have my credentials set. If I do a Terraform init, this is already initted. You can see, or initialized, I should say. And you can see I'm using I needed to pull the Kubernetes provider and the random provider as well. If I do a Terraform version, it'll give me the Terraform version as well as the provider information version that I'm using. And so I'll do a Terraform plan here. I'll send it to a plan file. And so what this is doing is it's looking at all of those TF files that I have, and it's figuring out what needs to go where, how it needs to deploy these things. And this will essentially deploy my entire thing here, all of the code that I've specified. So it's also going to launch a function and function app for me. We'll talk about that later as well. But you can see here that it's going to deploy my resource group. It's going to deploy my Kubernetes cluster. You can see all of the values that it's computing, all of the things that I set in variables. You can see my key information. It's deploying all of this here. So if I do a Terraform apply and give it that file name, you'll see that it starts to build. And this takes a little bit of time. This takes about 12 minutes, 12 to 16 minutes, just depending. So we're not going to be able to watch this build, but I do have one that has been pre-built. And actually, this is the same exact code right here. And you can see once this is done, if you do a Terraform plan after this has been built, there are no changes. So this is what you would see after the other build completes when you run a Terraform plan. And inside the actual portal, I have, on my dashboard, I have these tags set up so I can quickly get to these. If I go to this Ignite build, this is actually what gets built from that code. And you can see it building. Should be able to see it building here if I did these tags properly. Yeah, so it's already building all these things out for me, and they're still configuring. But if I go to the one that actually is already done, you can see it's built a resource group, it's built my Kubernetes cluster. All these things here at the bottom are related to the function. They're not related to the Kubernetes cluster. But you can see your Kubernetes cluster information here. You can see your API address. Another really cool thing that happens is I've set up some output. If I look at this output.tf file, it's giving me all of this output information. These are things that are exported from these resources that I'm setting as output. And so I set an output called client key, and I'm asking it to give me the client key as computed when it builds. But another cool thing that you can do is you can set yourself some helper notes, like I've set here. And so what I can do with this information is I can do a Terraform, is it Terraform output? Terraform show? Yeah, Terraform output. So what I can do now, if I can get past all this block of text, is I can simply Terraform output my entire kube config, if I can click this properly. Oh my goodness, okay. Live demos, they're the best, okay. So what I'm doing here is I'm using the Terraform output from kubeconfig, and I'm going to set that into this file.kube AKS config. And then after I do that, what I'm going to do is set my context. I'm going to export kubeconfig here. Why, Mac, why? Okay, let me fix this here. Okay, let me set this. And now I should be able to do a kubectl get nodes. Yeah, and so now I'm connected to this is the pre-baked one, but the other one will do the same whenever it's done building. I'm connected to Kubernetes, and I can use kubectl just as I normally would. I can do a kubectl proxy, and I can actually open up the browser. Oh, this one's going to be fun. Oh, wow. My Mac loves me today. So this will open, should have opened. Did I not do the proxy properly? Oh, that's what I did. I killed it. So let me do this. Here we go. Okay, there we go. So now I'm running through the kubectl proxy just like normal. And this is the actual cluster that I built for this demo. I pre-built it just to make sure it worked because live demos are fun. And you can see my services that I built. You can see my Nginx service here, the Kubernetes service that's running the API on this cluster. I can also see my the overview, of course, of this. I can see my pods. Anything that you can normally see. And really the point is that I'm using traditional tooling here. This is an AKS cluster. I'm connecting to it, but I'm using my traditional tooling. Okay, and I think we can move on now and talk about some functions. Let's see, let me get back to that. All right. So now we'll talk about Azure Functions. Who here has used or heard of Azure Functions? Okay, cool. So Azure Functions, they are serverless. And the reason I use my air quotes when I say serverless is because obviously somewhere behind there are servers. There is infrastructure running this code. The thing is, you don't have to think about that. You simply think about your code. You push this into an Azure function. We worry about that infrastructure. We worry about those servers. You don't have to, and that's a beautiful thing. And I think there's sometimes some confusion around the serverless word there. So you can create functions in the programming language of your choice. We are very big on not making anyone have to redo how they do things. Microsoft is really focusing on not trying to force people into, you have to use these sets of tools. You have to use this language. Obviously, there are times where that has to happen, but we're really, really pushing to not have to do that. You can add elasticity with functions that will scale to meet demand. So auto-scale these based on demand as well. It's super powerful. So what can you do with Azure Functions? These are a few examples. You can set a function that will take an event, process it, send some output to, say, a Cosmos DB. You can set one to run scheduled tasks, to do something scheduled, every, say, 15 minutes. You can set one as a backend for a web application. Say, something comes into this web app. It hits this URL. It can parse that data and, say, send it to a database or do something else with that data. You could also use one, and this one's pretty common actually, something that's watching in GitHub when a GitHub webhook kicks off. Say someone drops an issue, you can have a webhook fire off a function, and you can have it, say, output into Slack somewhere. Like, hey guys, there's a new issue, check this thing out. And these are just a few examples. Really, it's anything that you can dream up there. Azure Functions are super easy to create as well. Just like the AKS cluster, this is just using the command line. On this one, I'm showing creating the resource group. It's just extra there, but AZ group create will create a resource group for you. AZ storage account create is going to create the storage account that you need to store your function app data. And AZ function app create's actually going to create the function app for you. And this at the very bottom, and hopefully everyone can see that, this is super important. So there are certain things that have a global namespace inside of Azure. And storage accounts and function apps are some of those things. So the naming of these is a global namespace. If you build a storage account or a function app, they have to have a name that is globally unique. Otherwise, you'll get errors, and it'll just tell you that name is not available. So uploading content into a function app. There was actually a little bit of confusion for me when I started messing with Azure Functions because I'm used to other services and the way that their functions work. The way a function app works is a little bit different, but using the CLI, the AZ function app deployment through the AZ CLI, AZ function app deployment is how you would get things deployed into your function app easily. You can use source config or AZ function app deployment source config. You can give it a repo URL like that GitHub repo right there. It will deploy for you. You can deploy from a local zip file using AZ function app deployment source config -zip. And you just give it --src, the path to your zip. And this is really cool, this last one, if you haven't checked it out. AZ function app deployment source config -local-git, which is a lot of words. But what this does is it presents to you a URL that you can actually push to, and it will deploy to your function app. So that's really powerful for quick iteration on functions. You literally, here's a URL, do some work, push to it, check out your code. And of course, you can make some Azure functions in the portal if you'd prefer to. Under the compute section, they're actually called function apps. And there's also a tutorial there as well. And I think it's time for another demo. Yes. Okay. So there we go. And is that zoomed enough? Is it okay? Okay. So I won't show the rest of this because you've already seen it all. This is actually deploying a function app. So all of that stuff that we just talked through, to deploy a function app, you would use the resource in the AzureRM provider that's down here. Where we go? It's called function app. AzureRM function app is the resource that you'd use to deploy it. So this code from 56 to 73 here is all of the code that I need to deploy a function app, and actually to deploy a function that's working inside of that app as well. But let's go through this file really quickly. So I'm setting a random ID. The reason I'm doing this, and if you haven't seen this kind of block of code, this keepers block of code, what this does is it's watching my resource group through interpolation, and if my resource group changes, it changes my random ID. The reason I have a random ID is because those two important pieces of information, the storage name and the function app name, have to be globally unique. I'm just going to prepend this random ID on the end there. And that way I can make sure that it's globally unique. But I don't want it to make this name change every time I run Terraform. I want it to only change if my resource group changes. So that's what this weird little block of keepers up here is for. So here I'm creating the AzureRM storage account, and I'm calling it Ignite K8S demo, and then I'm using that random ID there on the end. I am using my interpolation for the resource group name for the location, and I'm setting my account tier and my replication type here as well. Setting my tags like normal, and I'm going to create an AzureRM app service plan here for this function. And the application service plan will let me decide if it's going to be dynamic, if it's going to be something that's done a certain way, if it's consumption or not, what kind of applications am I allowed to build through this service plan. I'm also going to deploy application insights for this function app. Who has used application insights? Right on. Awesome. Okay. Application insights will give me a little more in-depth look at my function, and I'm actually going to tie the two together right here in my app settings for this function app. And let me close this. Why do I have this open? There we go. This application insights instrumentation key that's actually going to be picked up through interpolation right here is what's going to link this function over to my app insights account so I can see some information about it as we use it. And this is to build the actual function app. And I'm doing Ignite demo for the name. I'm using a random ID on the end, so I have that unique name. And I'm setting the location, resource group name, app service plan ID, and storage connection string as well, all based on interpolation. That way nothing is hard-coded, and it's all based off what's computed. So this website run from package, this under app settings here for this function app, this was a little confusing for me, to be honest with you. I was trying to find an easy way to deploy just some sample code up into this function app. And this website run from package, the name's a little weird based on what I'm using it for, but it basically takes a zip URL and it will deploy it into your function app. And if the zip URL is set up properly and you have functions in there, it will actually deploy the functions for you. And so if you are using a tool like Terraform, this is what you need if you just want to simply take code and push it into that function app, website run from package. And you can see I'm using the variable that I showed you earlier that had the URL, and I can actually show it again really quickly. So this is the variable here on the bottom. That's where I'm pulling my demo code for this function app. So what I've done, because I already have some environments that already show this function running, I have this third one here. And let me redo this. Let me clear this. So Terraform plan, this is already running. This is a third environment that I have already running. And what's running on this environment, if I show you really quickly, is just this. So right now all I have is a resource group and I have my AKS cluster running, but I want to add this function to it. And I already have the function code there. So if I do a plan, it already sees that I have the Kubernetes cluster. It sees that I have my resource group. So all it's going to add is my app service plan. It's going to add my application insights. It's going to add my actual function and my storage account. And it's going to compute my random ID. And because I didn't do an out, let's just do an apply. So because I'm not using that out file, it's going to plan again for me, and then it's going to ask me, are you sure you want to do these things? If you give it a plan file, it assumes you're good with that. Like, okay, you've already seen the plan. You're explicitly telling me to apply this plan. I'm going to assume you say, yes, this is good to go. So here we go. It's building. Let's go back and look at the portal and refresh this. Yeah, and you can see things starting to build here. It just built my insights and my application insights. It set up my service plan. And this isn't a long-running one, but it does take a second. So right now, it's actually computing these resources and communicating with Azure and building this out for me. And we already have one that's already pre-baked. So let me show you that one as it works. And we don't have to wait for this. Not that one. OK. So this is the one that is already running. This at the very bottom with a lightning bolt is the actual function. Let's go into it. If it wants to load for me. Oh, it's waiting. All right, so here's my function app that it built for me. And you can see it's loading my functions. And so this was deployed using the same exact code. Once this loads, we'll see my function. There we go. So this was deployed using the same exact code. And what this deployed, this is a basic function. This is actually some of the sample code that you can pull. And what this does, it's looking for a query string, and it's just going to say hello and whatever the name string says. And so if I run this, we can see that I have a name of Microsoft Azure, and you can see the output is hello Microsoft Azure. And this is kind of hard to see. There's actually some logs here on the bottom as well. I can get the function URL and use this directly if I want to. So if I add name equals Microsoft Ignite, you can see hello Microsoft Ignite, and you can change that to whatever you want. But this is actually hitting that function that I have in Azure. OK.
Show the insights?
Yeah, let me show the insights real quick, just so you can see.
That URL a few more times.
I could, yeah, and I still have that up there. OK, well, let's look at the insights. So this insights is connected to the function that I just showed. So if we hit this URL a few times, and just to get some data in here as it goes live. So you can see there's actually a request rate coming in. The application insights, there's a lot more you can do here, and this talk doesn't cover application insights, so I won't go into it too much, but this is really powerful stuff. And this is a real-time live metric stream, which is super, super powerful. So I just wanted to point that out real quick. OK. Yeah, so I think we'll go into the next steps for you here. OK, next steps in getting started. So there's a few things that we want to mention here as we're winding down on the session. So these are some Kubernetes release automation tools to check out if you haven't already. Draft offers streamlined Kubernetes deployment. It's a very closed loop of deployment and development and deployment for Kubernetes. Helm is a package manager. You can think of it as like an apt for Kubernetes. If you need to install some kind of application, it will manage charts and templates for you. Brigade is event-driven scripting for Kubernetes, and Kashti is a visualization dashboard for Brigade. So if you want to check any of these out, they're named.sh, so draft.sh, helm.sh, brigade.sh, kashti.sh will get you to the right place. And there's also aka.ms/draft/helm and /brigade. Brigade will show Kashti and Brigade because they're pretty linked. And also, there's the Azure Container Registry, which is basically a private place to hold your containers. So if you need a container registry, check out the Azure Container Registry, also listed as ACR in a lot of places. Really cool feature of this really quickly is the Container Registry geo-replication. You can set up regions that you want to send and replicate your containers out to, and you can push to a single region, and the replication will happen automatically. It's a very powerful feature. And the Azure Container Instances, this is just deploying a container into Azure. You don't have to worry about Kubernetes or anything like that. You're just deploying a container without any of the other overhead. You can start using it right away. Hypervisor level isolation on this as well. And also, you can use the ACI connector for Kubernetes, or you can use virtual kubelet. And what you can do is tell your Kubernetes cluster to deploy to the connector, and you can spin up as many ACI instances as you want. The virtual kubelet on any Kubernetes cluster will look like a node and a kubelet that you deploy to, and it's actually deploying into Azure. And so that's super powerful. There's actually a quick visualization here, deploying some containers. We've got some waste, but what if we fill that waste up with pods? Well, if you use the ACI connector or virtual kubelet, you can just burst up into Azure and not have to worry about it. So also, get started today. Here's some documentation links if you want to snap a photo of this. You can sign up for Azure if you haven't already. aka.ms/free will take you to the free trial information. Try VS Code, because VS Code is awesome. aka.ms/VS Code is totally free, runs everywhere, open source. And check out these resources. aka.ms/TF Hub is the Terraform hub on Azure documentation. We have lots of great documentation there. aka.ms/Azure Docs will take you to the Azure Docs. Terraform.io/docs is the Terraform documentation. You can find out about providers, resources, how to contribute to Terraform if you want as well. And try out Terraform. I mean, it's a super awesome tool. It's easy to start with, and it's I don't know, I love it. It's cool. I'm not getting paid to say that either. Also, spin up an AKS cluster, aka.ms/K8s. That is a getting started guide that's actively worked on. It's not a stale guide, but that's a good getting started guide. It'll walk you through a lot of this stuff getting started with Kubernetes. And this is really important for us. Please evaluate this session. We really take the feedback and do something with it. We don't just ignore the feedback. Don't feel like it's a waste of time. And I know it's not fun to do a ton of surveys and feedback and everything, but everything that you give to us, we will make sure we improve on if needed. You can do that on the app, or you can do that on the website. Yeah. I think that's it, yeah. Thank you. So if you have any questions, just let us know. We have a few more minutes as well.
And be sure to step up to the mic because of the live streaming. Where's our QR code?
Hi, I'm coming from the Windows world, and I'm used to having someone hold my hand.
Yeah.
So when I'm editing all these TF files, thank you, holding my hand. When I'm editing all these TF files, is there IntelliSense or some kind of tools that will validate my schema or help me not to make mistakes when I'm entering all this stuff?
For sure, on VS Code, and I didn't show it very much, but on VS Code there's an extension marketplace where you can go and you can download extensions or you can make extensions yourself even if you want to. But there's a really good Terraform extension there, and it not only does it show you the IntelliSense, and if we can pull this up real quick.
I was going to show,
no, that's cool.
Validate too.
So if you take a look at this, on the left side of my screen, yeah, okay. So there's a Terraform Explorer as well. And what this does is it actually puts things in perspective for you. Here's my providers that I'm using. Here's the variables that I'm setting. Here's what I'm setting them to. So you can see my build tags. So this extension, the Terraform extension in VS Code, is super powerful. And VS Code's totally free. There's no charge for any of this stuff. And of course, you've got the IntelliSense here. It was actually upset at me earlier because the IntelliSense was updated this morning, and some of my code was missing something that's not necessarily required, but it was saying, hey, you might want to put this thing there. So I put it in there just so it wouldn't look like I had errors, but that's a good question.
And Terraform has a validate command too. That'll go through your config and tell you if there's any issues. Question, go to the mic.
I go to the mic.
Yeah, we have live stream just so they can hear.
I'm not from the Windows world. So I'm perfectly capable of holding my own hand. Anyway, this feels a bit like Mick Jagger. It's definitely not for the long people among us. So, honestly, when you see Cloud Shell working, it's a quite awesome tool. First question on that would be, If you're an enterprise and you're not too savvy with open up everything towards your Cloud Shell, which is basically running anywhere in the world, so I have to open up my IP range for everything. I miss that kind of in demos quite frequently. So that's the first question, and before you start answering, I also have a second one. Same goes for Kubernetes. If you run in an enterprise environment with a proxy, I have to open up a shitload of stuff. Kubernetes goes everywhere, all over the place. And again, of course, there are solutions for that, but I'm kind of missing this in demos. It's more like, okay, if we have your own account in your own Azure, no problem, Terraform will do everything. But once you start going into firewalls and proxies, etc., and enterprise security, then it's kind of a different beast.
Yeah, and definitely. And so, and just to make sure I reiterate this and that I'm thinking about this properly, you were saying the issue of all of your proxies and all of your firewalls and everything to make that connection to Kubernetes that becomes a problem?
It's at first the Cloud Shell going in, and secondly, it's Kubernetes going out.
Okay, so when you say Cloud Shell, do you mean the Cloud Shell that we have here that we were showing in the demo?
Definitely.
Yeah, so the Cloud Shell in the demo is really, I don't want to say it's not for every use for managing Terraform, but it's really good for quick iteration because when you're in that Cloud Shell, it's already authenticated to your account, so you don't have to mess with service principal information or getting any of that stuff set up. So it's really good for quick startups and quick demos, but most often, especially enterprises, they're not doing that kind of work in the Cloud Shell day to day. It's good to do quick testing, but it might not work for your workflow day to day. Yeah.
So I just want to say that you're totally right about when you get in an enterprise environment, a lot of those security issues take more time and resources to work through. And that's something that, since I work mostly with the open source practitioners, I don't run into a lot, and so I tend not to cover. But it's definitely something that, because I hang out in our sales engineering channels that work mostly with our enterprise customers, and I definitely see those questions going back and forth. And I don't know that there's any particular go-to solution because the issues become complex. And so, yeah, I don't have any particular tips other than, yeah, you're right, that is an issue, and it tends to be something our engineers and the ops within the organization have to work together to figure out, like get those certs figured out and stuff. Yeah,
I'm not looking for a solution over here right now.
Yeah.
But it's kind of what I'm missing in a lot of demos,
Yeah, you got me thinking
It's very easy if everything's open in your own.
Yeah.
That's kind of easy.
Yeah.
You've got me thinking about how to do a demo to show that, though. I'll put my thinking cap on.
The VNet integration, VPCs on AWS,
Right.
Yeah, and you can do similar things with linking your networking to Azure, but you are going to have to figure out, especially from an enterprise perspective, the firewalling and the requirements for your own networks and how disparate those networks might be. Another thing you might want to look at, and I can't remember the name of it, but there are certain things that you can deploy to clusters that will allow you to have what appears like seamless networking, but talking from one cluster to another. So maybe something like that might work for you. That would be a tunnel that's kind of open, that you've set the permissions and the firewalls around, and so maybe that would be something that works where you could deploy to AKS or something like that, and you would connect to this almost local proxy that's tunneling, where you don't have to continually open ports and make changes, because that can be painful, especially on an enterprise.
I just want to make sure we give time for.
And if you want to, we're going to be at the booth, just so everyone knows. We'll be at the booth at like 4 p.m. So if anybody has any other questions or wants to talk privately or anything like that.
Yeah, I have 2 questions. One quickly. Is there any reason why the logo for Azure Policies looks almost exactly the same with different color as the console one?
You mean the syntax highlighting?
No. If you check in the Azure portal and you pull out Azure Policies, the logo Azure Policies is almost the same as console.
Oh, okay.
HashiCorp console.
I have no idea. I need to check that out.
Have a
Okay.
look. It's funny.
I need to check that out, though, yeah.
A real question. Have you catch up on the Azure provider for everything related to networks, such as the new Express Route Gateway or the Azure Firewall, for example? Or is it still missing for now?
So it's constantly being updated. Honestly, I can take it offline and look for the specific things you need, but it's constantly being updated. And if there's something that's missing, definitely let us know or let me know, let anyone know. We can get the right resources on it. Typically, we're really good with having parity with HashiCorp, so it might already be there. But honestly, I can't say honestly.
I'll check. Thank you.
Thank you so much.
Just a quick one. I'm curious, with Terraform, is there a way to, or that it tells you like what's required versus optional as you're building these things? So you include the minimum things so that stuff works?
Yeah, so definitely, it's going to, like, say if I change something and I pulled out something that's required, if there's not a default, like if blank can't be default or something like that, it's going to complain and say, hey, you're missing this required value. So you have your resources, and then you have your attributes for those resources. There are certain that are required.
Does it give you like a starting template then that's already got stuff you need to fill in, or how would you start like from scratch? This is all pre-built.
So the way that I always start, and it might just be me, right? But I usually go pull sample code and start, like this looks right for me, and I'll just change these pieces. It's very, very, very kind of I don't want to say pluggable, but you can take snippets of code and put them together, almost like building blocks. But if you take a sample code or what have you, and you paste it in to say something with IntelliSense, even that IntelliSense and VS Code will tell you you're missing these things that are required. But if you ran like a Terraform plan and you're missing something that's required for that resource, it'll definitely say you can't go any further, you're missing these things. But it won't pre-populate that template. That would be something that the IDE would do. And honestly, VS Code, that's a good idea.
Awesome.
Maybe we can have an option in that Terraform extension that will pre-populate.
It'd be nice to say like I'm creating a network resource, and then it just it's the things I need to do.
Yeah, and the IntelliSense, as you start going, it will basically give you those hints like, hey, do this thing, and as you start typing, it will start to populate. But I don't think that it gives you a skeleton of each resource. But that's a good idea, though. Cool, thank you.
What is the advantage of using Terraform versus just raw ARM? I mean, I can do similar things via just AzureRM, right?
So and after this question, I think we'll have to take the rest offline because we're over our time. But the differences in ARM and Terraform, ARM is specific to Azure. And so when you deploy an ARM, also you're going to get a lot of log detail about what that ARM template did. And so you don't get that when you use Terraform. There's some things that ARM do that ARM does that Terraform doesn't, and that's really probably the biggest one. Is some companies require that for auditing. They want to see what the ARM template did. They want to see the output. I think it's the resource. I can't remember the name of it, but there's a specific name where it spits all that information out. But you can deploy ARM templates using Terraform. So if you have ARM templates, you can deploy them that way. The other thing I wanted to mention, and I lost track there. There's also Terraform Enterprise. So if you require governance and you require auditing and policies and things like that and more detail, Terraform Enterprise might be a good solution as well. And that actually gives you a user interface, and you can say this group of people has the ability to apply or approve a plan. So you can have people that do the work and then a group of people that approve it. It gets very granular using Sentinel. And the other thing with Terraform versus ARM, Terraform is multi-cloud, and ARM is going to be just for Azure. But if you are using Terraform for multi-cloud and you want to use ARM templates, you can just deploy them using the resource in the provider. Cool. Okay, cool. Thanks, everybody.